Hi, my name is Paco. I'm from Senzing, and I'm here to talk about entity resolution. Also, I'm joined with my colleague, Matthieu Besozzi from LInkurious, and we're here to talk about using entity resolution in the context of working with graphs. So working with link analysis, knowledge graph technologies, and that. But we're going to show how using these two technologies together, you can find the worst criminals and the best customers hidden in your data. So the origins of Senzing go back. Our founder, Jeff Jonas, he got his start in the mid-'80s in Las Vegas. He was working at the Mirage Casino in Las Vegas even before it opened. And while he was there, he invented a novel means of doing what's called non-obvious relationship awareness, NORA. And so that became a company. And then IBM acquired the company. Jeff became an IBM fellow. The company spun out of IBM in 2016 as became Senzing. And I should mention that in our core team at Senzing, most of the people have been working together for 20 years or more on entity resolution. We have an SDK for entity resolution. It gets used across a wide range of different application areas. So for instance, we're the majority of voter registration in the United States gets handled using our SDK. Also, a lot of different types of anti-fraud, various forms of counter cyber threat, counterterrorism, but also customer 360 and cleaning up marketing data and so on. About 60% of our end use cases are in what are called air-gapped environments. So these are highly secure, mission-critical apps. And as you'd expect, then a lot of it is in public sector. About 40% of what we do is in public sector, another 30% is enterprise, and then 30% through partnership. So entity resolution goes by a number of different names. You'll probably hear about deduplication or disambiguation or entity matching. And also there's a lot of important use cases. But I want to try to illustrate how this works, some of the important concerns. So on the left side, you've got a couple of records. Typically in your data or customer data, for instance, you'll have multiple records that have different descriptions, but they're about the same entity, about the same person. So ultimately, you need to know that these need to have like an emerge or some sort of handling as one entity. But then you're also going to have other records that overlap that have similar descriptions, but they're different. So here, there's Bob Smith Jr. and then Bob Smith Sr. And you need to be able to distinguish those two. The other important thing that entity resolution does is to tell you about the relationships between the entities. And that's very important when you go to be working with graph technologies doing link analysis. A fact of life is that a lot of times the fraudsters, but also your best customers, will be hidden somewhere in the data. So we talk about having your data hiding in plain sight. Entity resolution provides you with means to uncover the hidden connections in your data. So we talk about finding the footprint of entities across different data sources, identifying that they're connected. And I'll illustrate here, we use an approach called entity-centric learning. So on the left side, let's say you've got two records, Rob Smith II and Rob Smith, aka Bobby Jones, as an alias. And then a third record comes in for somebody named Bob Jones. If you're just comparing record to record and doing string comparisons on the fields, you'll miss that. You won't see that these are connected. On the right side, we're showing about entity-centric approaches. What we do is it's a more holistic approach where we look at all the different features and attributes across the data sets, and we try to triangulate on what are the entities that are represented. That's an overlay on top of your data records. And so it's pointing to your data records as evidence for making those decisions about merge or disambiguate. And so I'll try to illustrate here. We've got this case. There's something called channel separation, which is a kind of tradecraft that's practiced amongst fraudsters. The idea is you've got a known money launderer, let's say Bob Jones, and there's his address and his phone number. By doing channel separation, Bob Jones is going to go in and set up other accounts. Each time he sets up an account, his personal information will change just a little bit. So the data drifts. And eventually he sets up enough accounts that in the middle, he's opening a new account with entirely different identity. By using entity-centric learning, we're able to show that this new account, it's actually one person, he's on a watch list, and you need to take action. And the devil is in the details. I'm showing here about name comparison. This is where it shows how the edge cases for entity resolution are very far, but the edge cases are also where the business value is. So here's an individual. I studied Arabic a long time ago, and my pronunciation is horrible, but I'll try. But if you have an individual here, Abdullah Kadaf, and if I were to translate from Alukat al-Arabia into English, that could be spelled multiple different ways. So doing a string comparison really doesn't work. And also, on top of that, if the individual has made a pilgrimage, he might have a prefix, like here he's got al-Haz. Or, if the child of somebody who's famous, he could have a suffix like bin and biak. So with Senzing entity resolution, we're able to tell these are the names of the same person. And then conversely, if you think about this, John R. Smith and John E. Smith, if you think about this in terms of voter registration, these are two different people, but the names are only one letter apart. So this is where it gets really complex in the edge cases. And the takeaway here is that cultural norms determine the kind of comparisons you need to make for effective entity resolution. And so Senzing provides 80 different globalizations to support those kind of cultural norms, make those decisions in a very powerful way. This is an address in Singapore. I've been to this location. It's at Orchard Tower Plaza. It's a really beautiful area. There's a confluence of different cultures there. So street addresses get abbreviated all over the map. It's really crazy. But we're able to tell that these two very different strings are the same address. And then if you take yet another form of that address and compare with one of its neighbors, those strings are only 2 letters off, but we're able to tell those are 2 different businesses. And your developers will appreciate that with Senzing, it's JSON in and JSON out. So integration is very simple. We have SDKs in Python and Java, and typically it's about 3 lines of code in either language. You may be using entity resolution in some sort of data engineering workflow, like you may be bringing together different data sources that you have and cleaning them up, or you may be taking your customer records and enriching them with some third-party source. Another thing you may be doing with entity resolution, though, is working with graph technologies. So that's my specialty, is working in the knowledge graph practice area. And for this, I will turn over to my colleague, Matthieu Besozzi, who is the head of North America at our future partner, LInkurious, to show a demo of using Senzing entity resolution and LInkurious link analysis. Again, finding your best customers and worst criminals in your data. That's it.
Thank you, Paco, and thank you for being here. I appreciate that. So my name is Matthieu Besozzi. I'm from LInkurious. So what is LInkurious? Just in a nutshell, we have a tool called LInkurious Enterprise that is a link analysis tools. It sits on top of graph databases. So basically, you would have graph databases, and this is a tool for business users. So basically, it's a tool that provides all the capabilities for users to explore connected entities, to run complex queries, to view the graph on a map, to access to alerts, comment, collaborate, a lot of stuff for business users. So why is entity resolution useful in the context of graph? So let's think about, a bank. So you're a fraud analyst, for instance. Okay, so here you have 2 clients, one in blue, one in red. Okay, the guy in blue, so he has a phone number, he has a bank account, he has a home address, he does transaction, credit cards, so everything is fine. And the guy in red is actually a person that has been already identified as suspicious, and all the transactions have been blocked. Okay, if you miss here, there is something that is actually linking those 2 persons, because actually they are the same. Okay, and without entity resolution, you're having a hard time to actually do this connection. And this is why we believe Senzing is useful, because if you have 2 clients or 2 companies mapped into your system where there is actually just one entity, then you are missing a lot of the context around the entity. And I know very well what I'm talking about because I want you to introduce me and my multiple identities. So my name is Matthieu Besozzi. I know I have a perfect accent from Texas, so you don't realize that I'm actually a European, okay? I have a first name that is French, a last name that is Italian, okay? Matthieu Besozzi. So here in America, everybody call me Matthieu Besozzi. So they misspell it. Some people call me Matthieu Besozzi with just one T. There is two T in my first name. A lot of people actually don't know where is the S and where is the Z, okay? So they get confused. And sometimes they just forget there are S's, so I just have D's. And my favorite name is actually my name on my passport. Because in France, we don't have middle names. We have 3 first names. Matthieu Besozzi, Stéphane Bernard Besozzi Ortoli. This is my name. So these 5 people are actually the 6, the same person. So let's think about, Amazon, CVS, who else? United, they have multiple Matthieu Besozzi with different spelling. It's actually the same person. So if you're doing client, customer journey, whatever, you're missing a lot of context if you're looking at me because I'm mapped as multiple entities. So here, let's see how it looks like on a graph. Okay, so here you can see an entity A, could be me, it could be a person A, and we have some, entities connected to this person. And here you have another one, A, still the same, probably different spelling or I don't know, a typo in the social security number or in the phone number with a different context, okay? Actually, those 2 guys are the same. So on one side, you have a context, and on the other side, you have a different context. So now let's try to reconcile, to resolve, the duplicated entities. So you will see that A, you will merge A with A, B with B, C with C, F with F, and you will end up with a simplified graph with more context because you're not missing anything. And now that you have something that is simplified, you can add, external, data source or whatever. And then you get the real context around this person A. And this is actually what we're doing at LInkurious. So remember, we are a link analysis tool for end user, for business users, and we actually integrated the entity resolution as part of the process. So here I want to show you how we can do the entity resolution on the platform. So here we are first mapping the entities. So here you see this UI where we are mapping very easily the entity on the whole data set. Could be billions of entities. Here we are mapping the persons. So we need to say, okay, we want to focus on this kind of nodes, and here is what kind corresponding properties in my graph. So here we want to select the full names of the officers. Here we go. Here we want to select the country of the officer, country of the address. Okay. Now it's done. We save the mapping. And then we can review it like that. We can validate, and you can start the mapping. And it's just one click, and you get the whole data set mapped. Like that. You see, it's easy. So now that it's mapped, you can go to the next level. And we are going to resolve the entities. So now that it's mapped, okay, we can see how it looks like on the graph. And so I will look for one of my contacts in my data set, a guy named Peter. I don't remember. Yeah, this guy. Okay, so here you see that this is a person that I found in a Pandora paper, and there is one resolved entity, okay, like that. And here, if I expand this resolved entity, we can see all the different entities in which the name of this person has been found. So actually, I had 3 persons in my data set that are actually exactly the same. So now that I've resolved the entity, I can merge all these people into one node, a super node that is representing the person. Okay, so this is just for one node. So now we can see how it looks like at the graph level. All right, so here you can see a graph with various entities, and among those entities, you can see in blue the persons, okay? So now, if I want to see how the entity resolution looks like in my graph, I just click here on play, and here you can see that I am able to merge all those entities and to get a very simplified result of my graph. Okay, so I've been able here to actually identify all the persons that were duplicated into my graph, to merge all these nodes and to create like super nodes that I can use in order to do my investigations. So I resolved this huge pain point of duplicated entities very easily. And now I just want to show you a last slide, just to tell you, I don't have any shares in Senzing. I'm not paid to come here, so I just want to tell you why we picked Senzing as a partner for the entity resolution, because there are plenty of options out there. But what I find interesting with Senzing is explainability. This is very important. We've looked at a number of different options for entity resolution, and what is great with Senzing is that for each node that are resolved, Senzing explained why. That has a lot of value. And then, because we create, a resolved entity, if you're not happy with the result, it's fine. You can go back. I've seen a lot of entity resolution tools in which that is actually, deleting entities or changing stuff, and you cannot go back. So here it's possible. Time is up. So last thing is the speed and scalability. Very important. Senzing can work on large, huge data sets. Okay, billions of entities can be resolved very, very fast. So this is the most effective and powerful entity resolution tool that exists out there. So that is the 3 main reasons why we picked Senzing. So thank you very much for attendance. I really appreciate it. Have a good day.